Hi, I'm Khattab. I work at Amal Africa, which is a social enterprise that was set up in Sudan to help youth get access to IT. There are thousands of graduates leaving university every year,
Hi, I'm
and
Khattab. I
only a
work
few
at
of them
Amal Africa,
get
which is a social.
good jobs. So, in that note, Amal Africa was established to try and provide these talented youth with good jobs, both locally and internationally, and also get guidance on how to succeed as an engineer or a developer. And so we are now in the process of setting up our first boot camp, which will basically train and help provide students with jobs instantly. And also, we are doing the series of webinars so we can get more people involved because we had more than 900 applicants in the course of 2 weeks or so, and we can't accept all of them. So we're trying to host these webinars to help get more people involved in the process. These webinars are basically a series where we host engineers from all over the world so they can come and share their knowledge with us and try to give people tips on how to excel as engineers. Here with me tonight is Chris, who will be hosting our second webinar that is titled Python 3. And for those who are on the call, you can use the chat tab to ask questions, and I will make sure I forward these to Chris at the end of the session. So Chris, over to you.
Thanks, Tab. So hi everyone, I'm Chris. I've been a software developer for about 4 years. I've recently started working for a small consulting company called BigAvocado over at the UK. And a little bit about myself. I graduated from the University of West of England with a degree in software engineering, and I spend sort of a lot of my free time. I like to play badminton. I tend to do a bit of skydiving as well. I'm training to be a level 1 skydiver, which is a bit scary, and I also like to do sort of introductions to programming and sort of charitable things like this in my free time. So getting on with things, what we're going to cover today is an introduction to Python 3, and this webinar is mainly aimed at people that don't really have any experience with programming before, or have maybe done a little bit but haven't really looked at Python before. But it should be approachable to people of sort of all levels. So we'll cover a lot of the sort of very basic concepts that you'll find in all programming languages. We'll also go through some things that are specific to Python. So we'll talk about the REPL. We'll talk about some of the sort of fundamental things in Python 3, and then we'll move on to writing our first program in Python, and then testing our first program in Python. We're going to assume at this point that you've got Python 3 installed on your PC, and you've got some kind of text editor that you can work with to write your code. This might be something, if you're on Windows, you can use like Notepad, that's fine. But if you've already done a bit of coding before, you might have something like Atom or Sublime Text installed. I think some information went out prior to this with some suggestions on software that you need to get started. Okay, so getting started with fundamentals and the REPL. So what is the REPL? The REPL stands for repeat, evaluate, print loop. And that is what we call the Python runtime. So that is the environment or the sort of application that we use to run our Python code and sort of enter and execute Python commands. It's a kind of an environment. It lets us run sort of 1 or 2 lines of code at a time. It allows us to experiment and do what we call spiking, which is where we just sort of do test out small bits of code and kind of experiment around and see if what we can do with different bits of Python. And then if we kind of get to the answer or the solution we want, we can then take the work we've done in the REPL and kind of put that into a bigger program or a more complicated program. So some of the things before we sort of get stuck in with the REPL, I'm going to talk a little bit about the fundamentals of just programming and sort of some concepts that you'll find in pretty much any programming language. So we'll start with the first one being variables. So a variable, if you've got a background in mathematics, some of these things might kind of be familiar to you. A variable is essentially a kind of a temporary storage for your program. You can store small bits of temporary data to operate on or sort of perform work on or calculations on, and you'll use variables all throughout your program. Whatever it is you're doing. The second thing is types. So types are a very important concept in every programming language. Some more so than others, but you'll find it in pretty much every programming language you come to use. Types are essentially how we represent our data in our program, how we think about our data and how our program will kind of interact with it and how it will use it. So examples of some types are things like integers, which are whole numbers. So 1, 2, 3, 4, 5, and text. So that will be words or sentences and things like that. And we'll cover a little bit more about that in the next slide. Another example is something like decimal numbers, and sort of fractions and things like that, which are distinctly different from whole numbers or integers. So the third thing I think that needs to be discussed is functions. So every programming language has some concept of functions. A function is a concise kind of repeatable action or solution that you have in your program. And again, if you've got a background in mathematics, you might have a sort of already familiar with this. So functions will take parameters. They'll take sort of values that you give to them. And then inside the function, there'll be some work that's being done, some data that's being processed. And then the function will return a result or will give an answer in return, and which you can then go use sort of in your program something else with. So functions are a really important concept in programming. Without functions, a lot of our programs would be very hard to keep track of and maintain. The fourth thing that I want to cover is operands. So operands are parts of the Python programming language that we use to work with or manipulate 2 or more variables. So again, if an example of an operand might be something like adding or subtracting or multiplying 2 variables together. And yeah, essentially things that aren't really as quite complex as, say, a function, but are still kind of discrete operations that you would perform on data. And then you've got input and output, which can mean many different things, but in the context of this exercise, we'll be thinking of input and output as taking sort of some input or text from the user, and outputting it will be printing it to the screen or writing sort of text and responses back to the user. But generally speaking, you could think of it as how your program interacts with the user, or how data is passed in and out of a function. Okay. So some of the basics of Python 3 programming. So we're going to go through, I'm going to take you through working with sort of arithmetic using the REPL. We're going to talk about what it's like to work with text and manipulate text. And then I'm also going to introduce the concept of libraries and working with sort of sets of functions and some of the functions that are available in Python. So we're going to go ahead and we're going to start the Python REPL. So if you've got a Windows machine, you want to open up command prompt at this point, or you might have PowerShell installed, but I'd recommend command prompt. And if you're on a Mac, then you'll want to open up Bash. So what we're going to do is, if you've got your command prompt or sort of terminal open, we'll go ahead and type Python 3. Assuming you have this already installed, you should be able to run the Python 3 command. And then that will produce the REPL as we see it here. You'll kind of get some text saying you've got, this is what version of Python we're running, and then you've got these kind of funny arrows here. And this denotes that Python's kind of ready to receive a command or to read some code. So what I'm going to do now is I'm just going to take you through how to use the REPL and some of the basics of Python programming and some of the sort of the syntax fundamentals. So so there are two important things I would say when working with the REPL. You can basically just immediately start typing code into the REPL. So if I start typing in some sort of mathematical like calculations, if we press enter, then the REPL will take our code that we've written here, our Python code, and it will immediately return a result back. And as we write more advanced Python codes, we might need to start thinking about how we would break the problem down into different lines and things like that. But we'll get onto that a bit later. So another thing that's important is that you can use the up and down arrows to go through previous commands that you've ran inside the REPL. So the first thing I've just shown you there is how to do addition. So that is what addition looks like in Python, which I think is how addition looks like pretty much everywhere else. So I won't spend too much time really explaining that. Similarly, you would do subtraction like so. And you would, again, pressing enter, you get the result that you might expect from doing that. If we want to do something like multiplication, you would use the asterisk symbol, and you would use this to multiply two numbers together. You can't use the x. If you do that, then Python will get a bit confused. It will think that x is a variable or perhaps the name of a function. It usually associates letters with code syntax, not as operands. So Python and like many other programming languages, you use the asterisk symbol to do multiplication. And then in a similar way, if you want to do division, you use the /. And again, I mean, I don't have a divided button on my keyboard, so I don't think there's any other way you might do that. But yeah, so we use the / to denote division in Python. And then something else that I'll cover quickly is also exponents. So if you wanted to do 2 to the power of 4, you would use 2 asterisks like that. So we could do 2 to the power of 3 and get 8 as you would expect. So it's pretty straightforward. That's how you would, if you were to do just some basic maths in Python, that's how you might go about doing it. I'm going to move on now to talking about text, and I'm going to cover a few different functions. I'll introduce you to what a function might look like, how we represent text in Python, and how we can use those functions to manipulate pieces of text and strings. So what I'll do now is I'll show you how we represent a string in Python. So strings in Python are represented with these quotes. And then in here, I can write a sentence like, hello, my name is Chris. And if we just shoot this straight into the REPL, we haven't really asked it to do anything. So it's just going to tell us the text back. However, this is distinctly different from if we remove these quotes. Python will now interpret this as like an actual line of code, not as some sort of literal text. So if I press enter now, it will give me an error message, and basically it will say invalid syntax, which it's right, because this isn't code, this is a sentence. So sort of again, that's a way of illustrating the importance of types, and especially that for things like strings, it's very important to surround your text in quotes, so Python knows what kind of data it's working with. So the next thing I want to talk about is what kind of operations you can do with strings and text. So operations in Python and other programming languages will often behave differently depending on what types of data you're working with. So if we take the addition symbol, for example, and then we want to add 2 strings together. So if I say, if I just add another sentence here, like ice cream. You like ice cream. And then if I enter this, what Python will do is it will add these 2 sentences together into a single string. So the result we get back is just 2 quotes, one at each end, and then the full sentence that we've added here. Obviously, this is quite a different behavior to adding 2 numbers together, and Python knows to do that because it knows what data types it's working with. And just to again illustrate the importance of data types, I'll show you what happens if you try to add things that are of 2 different types together, and sort of what might go wrong. So if I modify our sentence, and then let's say I want to use, I want to say that I'm 55 years old. We'll just say I'm 55. We'll get a sentence back, and that's all fine because we've told Python that we're working with some text here. But if I say, instead of use the sort of sentence 55, I give it the literal number, the integer 55, Python will give me an error and saying that you can't add a string to a number because that doesn't really make a lot of sense. And likewise, so again, types are very, very important in when working with data. So something else I'll just show you quickly as well, and another example of how functions behave differently, or operations behave differently depending on types, is if we use the multiplication operand. So if I say, hello, my name is Chris as a sentence, and then I multiply this by 5, I will get that sentence 5 times, which may be intuitive to you. It may not be, but that's what happens. So now I'm going to talk about functions, how we call a function, and how we'll sort of pass data into a function. So there are a couple of functions in Python that we can use to work with and manipulate text and strings, like we have here. So the first one being that I want to take us through is the find function, and that will tell us where, if we search for a word or a letter in a string, it will tell us where that word and where that letter is. So what I'll do is I'll take our sentence, and to call a function or to invoke a function, we take our data, and then at the end of it, at the end of our data, we put the dot, and then the name of the function, which in this case is going to be find. And then around inside these sort of rounded brackets is where we enter our parameter, and we would say we would enter the text that we want to search for. So in this case, I'm going to put my name. I'm going to search for my name. It's going to give me the number 17 back, and what this means is this is essentially the count of the beginning of where that word is. So it's saying that this is the 17th letter or character in this sentence. Is where you can find the word Chris. And so, yep, so that's the find function. So the next thing I want to take you through now is the replace function, and it works very similar to the find function. In that the first parameter we pass into the function is what it is we want to look for, and then the second parameter that we'll pass into the function is the text that we want to replace it for. So if for the replace function I type in Ross and run that, we'll get a command back that says, hello, my name is Ross. And as you can see, obviously it's replaced my name with Ross. When you're calling a function with multiple parameters, those parameters are separated by a comma, always separated by a comma. Okay, so there are two more functions I wanted to take us through: the split function and the length function, and then we'll move on to the next. Move on to the next bit. So the split function. This is something that you will essentially pass in. Our parameter will be again a word. It kind of works similar to find. It's a word in our string that we want to search for, but what it will do is it will split the sentence in half. It will split it into two separate strings. So what I'll do is I'll enter. I'll search for the word name. And if I run that, as you can see now, it's split the sentence into two. We've got one here denoted by the quotes, and then a comma, and then another one here. So hello, my, and then is Chris. And then we've got these kind of square brackets here. Now, these square brackets denote what's called an array, which is when you have like a list or a set of variables. I'm not going to go into arrays too much in this lesson. You can do an awful lot with arrays in Python, and it's probably kind of almost a topic in itself. So I'm just going to kind of leave that with you. You can there's plenty of materials online that can sort of show you arrays and what can be done with that. And then the final function that I wanted to use was the length function. So the length function will take a variable, and it will tell us how big that variable is, depending on what data type we give it. So if we pass in a string, so I'll put my name in, for example. Now it's slightly different to how we've called the functions before, because the previous functions we've taken our string and then we've called our function off of the back of it. Whereas the length function doesn't actually need a variable to be called off of. It's available to us all the time. And the parameter that we pass in is just whatever it is we want it to count. So I can go ahead and I can run this, and what it will do is it will return the length of this sentence, which is saying it's 5 letters. So that's pretty much it. That's how you work with text, how we represent text, and some basic functions you can use to manipulate text. The last thing that I'll briefly introduce is libraries and using standard functions that are within Python. So we've already used a few standard functions, but what I'll do is now I'll take us through importing a library. So I'll take us through importing if we wanted to take the maths library, if we wanted to do something like, I don't know, calculate the square root of a number. In Python, the square root operation is a function. It's not an operation that's built into the programming language. So we need to import a library and call a function to enable us to do that. So to do that, we'll use the keyword import. And this is what we call a reserved word in Python. So only the word import can only be used for bringing in libraries. It can't be used for anything else, like the name of a variable or the name of a function. And I'll go over just for a minute talking about what a library is and how they come about to be created. So a library is essentially a collection of functions or a collection of solutions to problems that other people have made and have given out or sold perhaps for developers to use. So the square root function, for example, it wouldn't be very useful if every time you went to write a program, you had to write your own function for square root. So that problem's already been solved and is shared with us. There are absolutely loads of libraries for Python for solving and working with all kinds of different problems. So I mean, and if you're interested to see what's out there, like a quick Google search will help you find all kinds of all the libraries that are available to you in Python and what kind of things you can do. But anyway, so moving on, if we go ahead and we import the maths library, and then if I want to perform a square root operation, I'll then use the name of the library and then dot like we used before, and then I'll call the square root function, which is sqrt, and then the parameter for our function will be, I want to know the square root of 9, so I'll pass in 9, and then the result we get back is 3. So I'm not going to go into any more detail about libraries or working with importing libraries and things like that. That's probably something that could be covered in another session or something that you could go and research yourselves. But that pretty much covers like a lot of the basics in Python and working with the REPL. So what we're going to move on to now is we're going to write our first program in Python. So this script is going to take we're going to take some input from the user. It will be they'll enter their age. We'll create a function that calculates their birthday, or at the very least the year that they were born. That's just about all you can calculate from someone's age. We'll perform that kind of process, and then we'll print the output back to the user. So the way we're going to do that is to start off with, if you've not already got it open, open your text editor now and create yourself a new Python file. So this file, it should end in .py. So I'll call this birthday later. And then just so your operating system knows that it's a Python file, I'd put .py at the end. Okay, so now we have our script. The first thing we want to do is take user input. So the way we can take user input is we'll use the, as you can imagine, the input function. So the input function takes one parameter, which is a string, and you can use that string to prompt the user or give some feedback to the user. So we will ask them the question, what is your age? Okay, and before we do anything, we're now just going to run this and make sure that it's working properly. So to run our code, to run our script, we want to first close down the REPL. To close down the REPL, you call the exit function, which is simply exit with no parameters. And then we go back to our command prompt. And then what I do to run a file or a Python script, you would say Python 3. And then instead of just running it at this point, you would put the name of the file. You type the name of the file like that. And then if we go ahead and run it now, what we can see is it's asking me for my age. So this input function that we had here is asking me to enter something. So I'll say something like 26. And then the program finishes because we haven't written any code yet. And that's fine. So what we want to do now, we've got input. And now we want to, oh, sorry, sped forward there. And now what we want to do is store that data in a variable. So variables are pretty straightforward in Python. To declare a variable and store some data in a variable, we simply just type what we want the variable to be called. So I'm going to call it age, and then we use what's known as the assignment operator, which is this equal symbol, and this is telling Python that whatever is returned by the input function, we want to assign to the age variable. So if you kind of follow it backwards, you can see where the data is flowing in the program. Okay, and then we've got our age stored here, and then if we want to just print that back out and show the user that we've stored it, we can call the print function, and then we'll pass in the age variable that we've stored. So we've now got a little bit of a more complicated program, and we can go ahead and run this again. If I just press up and then press enter and run that, it will ask me for my age again. I'll say I'm 26, and then the program prints out my age. So it's storing it. We've got our variable, and we're printing output. So now what we want to do is actually do the calculation and work out what year I was born in. So to do that, we need to create a function. To create a function in Python, we use the def keyword, and def is essentially short for define, not like you can't hear or anything like that. Def is short for define. So we'll use the word def, and then we'll type the name of our function. So I'll call our function calculate birth date. And then very important is that we add a colon to the end of our function. That way Python knows that the subsequent lines of code are part of this function and not part of the script, so it won't kind of execute it in the order that it's necessarily written in. And then there are essentially two important parts to a function. So the first one is the parameters, the data that's passed in. So the data we want to be passed into our function will be the user's age. And then we want our function to actually return something as well. Just for the time being, we're going to just make it return like the user's age plus 10, just to show how we might use a function. And then what I will do is over here, I'll have another variable for new age, and we'll call our function and pass in age here. And what you can see here is that essentially this doesn't really look any different to any of the functions or how we've used any of the other functions before. Obviously, we haven't gone across definitions before, but once you've defined your function, when you go to use it, it's not really any different to what we're doing up here or what we're doing over here. So now, if I go ahead and run this this script. Where's my age? 26. Okay. And what's going to happen now is, or what's happened now, is our script has run into an error. It said that it must be a string and not an integer. And that's, again, emphasizing the importance of types in Python. And the reason why that's happened is because the result that's returned from the input function is a string and not an integer. And here we're trying to add the number 10 to what is a string. Even though it's the number 26, it's represented as text, not as a sort of a whole number. So the way we can work with that is if we can use another function called int, and int will essentially convert our string to its literal integer counterpart. So it should convert the string 26 to the number 26. And what we're doing, so we're calling the int function. We're passing in the age as text, and then afterwards we're adding 10 to it, and then we're returning all of that out of our function. So there's quite a lot going on in this line of code, but that's what it's doing. So now if we run it again, now it will, as you can see, it adds 10 to my age, and you've got 36, because we're now converting it to the correct format. Okay, so moving things along now, what we're going to do is we're going to try and calculate the year that I was born based on the input that I give. So to do that, we're going to need to bring in a library. When you're working with dates and times, it wouldn't be great if we had to create our own functions and sort of ideas around date and time and things like that. Luckily, someone's already figured that out for us, so we can take what that person's done and take their library and use it in our program. So to bring that in, we're going to introduce what's called the datetime library. So to do that, I'm going to use from datetime, import datetime. And so with this line of code, we can import the datetime library into our script, and then we can start working with it here. And then what we want to do next, if we think about how we want to calculate the year that I was born, it will essentially be we want to take the current date of today, or at least the current year, and then we'll want to take my age, or we want to subtract the user's age away from that year. So to do that, we have a nice function called datetime.now, and that will give us back the today's date, essentially. And we'll want to store today's date in a variable, so we'll call that current date, like so. And we'll assign it, again, we'll assign the result of the now function to its current date. And then within the current date variable, there will be several other kind of things that we want to work with. The current date will have seconds, minutes, hours, the day of the week, the month, all of those different things. But we're only really interested in the year. So to get the bit of the variable that we're interested in, we can use current date and then .year, and this variable here will give us back the year that we want. So, or give us back the current year. And then with that, we can subtract the user's age that's whatever's passed into the function, and then we'll want to store that in its own variable, which will be let's say user year born, like that. So we're doing our calculation here. Now, what's important though still is that we actually continue to convert it to an integer. Otherwise, we'll run into the same problem that we had before, like that. And then we can just go ahead and return the year that the user was born. Okay, so now what I can do is if I run our script one last time, my name in, and what it will return now is my age, the year I was born, which was 1992. And we can try with a few different ages. So I'll put 30 in, and it'll give us 1998, which 1988. So yep, that makes sense. I was reading that wrong. 1988. So that's essentially it. That's our first program in Python. Very simple. We've covered taking user input, storing that input in variables, creating a function that we can use to kind of encapsulate the core logic of our program and our functionality, and then printing the output back to the user. And we've also done a little bit with converting types and working with different types of data. Okay, so now the final thing that I want to take us through this evening is testing our program. So in professional software development, there's a very important practice called test-driven development, and that is essentially where we write what's called a unit test for our program first, and then we write the sort of the code of our program second. And what that allows us to do, it gives us two things, or I'll explain two benefits of it at this point. One is that it can drive the development of our program in a way that's a bit more constructive and a bit more linear. And the second thing is it can tell us when exactly we're doing something wrong, compared to when we might not be doing something wrong, but we wouldn't know because we're not getting an error or some kind of feedback. So it creates a really good feedback cycle. So to create our unit tests, we need to use a library called PyTest. So to install PyTest in your command prompt, you want to type in pip install PyTest. This should only take a couple of minutes to install. And then once you've got that in, you'll be able to write your unit tests. And unit tests in Python are essentially just, they are functions that we'll use to call other functions. They'll pass in parameters, and then they'll take the outputs of those parameters and they'll check to see if the results are what we expected them to be based on what we passed into the functions. And I'll explain all of this. We'll go through this and we'll rewrite our program using tests now. So what I'm going to do now is I'm assuming you've got pytest installed. So what we're going to do now is we'll create a new file. And I'll call this same as before. Tests. And then what we're going to do is we're going to write, first of all, a unit test. Instead of writing anything to do with our program, we're going to start writing the unit test. And a unit test, like any other, is a function like anything else in Python. So we start with the def keyword. When we're working with pytest, we have to begin our function with the word test. And then here we're going to write sort of the name of our test, or roughly what it is our test is doing. So I'll say when user inputs 26, correct year is returned. Okay, so it's a bit long-winded, but if someone else was to come along and look at this, I think hopefully they would sort of be able to see what's going on here and what the point of this test is, and that's very important in programming. So the next thing we're going to do is we're going to just think about what it is our test function should actually be testing for. So it's going to be passing in the input 26, and we're expecting the year 1992 to be returned. So to do that, we need to call our calculate birthday function. We need to call our calculate birthday function. We want to pass in the age 26, and then we'll want to take the result of the function and store it in a variable. So we'll call that birth year, and we'll assign the result of that function to that variable. And then what we want to do is we want to then check if the test is actually passed, if the birth year is the correct year that we expect. And to do that, sorry, I just need to move that over there. And then to do that, we use the assert keyword. And the assert keyword is basically our way of telling Python that, look, we expect this to equal this. We expect this to be the result of our function here. Okay, so what we can do now, we've got our test set up, and what we can do now is we can go to the command line, and instead of typing Python 3, we're going to type pytest, and then birthday calculator tests, and go ahead and run that. And then what we'll find now is we get quite a different response when we run pytest compared to running Python 3. And what we get is we get an error saying that our calculate birthday function is not defined, which is fair enough. It's not. We haven't defined this function in this script. We've only defined our test. So the test is a failure. Basically, we've got our one test, so we know that our program's not complete, or there's something wrong with it. So what we'll go ahead and do now is we'll go ahead and we'll define our calculate birthday function, like so. And then obviously, like every other function, it needs to have the colon, and it needs to return something. So we've done that. So that should now fix that problem. So if we go ahead and run our test again. Okay, so now what we've found is we've moved on, but we've got a different error. It's saying the function is taking no parameters or arguments. Another word for parameters is argument, but we've given one. So obviously, in our test, we've said, well, we want to pass in 26 function. The definition of the function doesn't take any variables, so we need to define what our parameter is. Okay, so we'll do that, and that should solve that problem. And what hopefully you can sort of see now is by using pytest, I'm kind of I'm using that to drive the development process of how we're building out our function and our program. And it's a much more kind of constructive and it's a much more sort of constructive feedback loop, as opposed to just running the script over and over again with different inputs like we had before. So if I now go ahead and run it again, it's going to tell me that the test is still failing because what's being returned from the function is not 1992, which is quite right. It's not returning 1992, it's returning nothing. And this is kind of, I think, one of the, at this point, the main benefits of unit testing. So if in this return statement I was to put 1993, so we're not actually doing any work at this point, we're just going to return sort of a number out the back of our function, and run the test again. The test will still fail and tell us that the result is 1993 when it should be 1992. Now, this is a really important point, and it really highlights the value of unit testing, because if we go back to our original, the first version of our program, and I type my age in, actually, sorry, let me, if I type my age in, we get 1992 back. If I edit, if I change our original program to what we've just written and just make it so that it always returns 1993, and then run that, it will ask for our age, and then it will just return 1993. There's no error. There's nothing wrong with the program, but it's still giving the wrong result. And unless someone was very acute and they looked at that and they go, oh, that's not quite right, you wouldn't necessarily know that there was something wrong with the program. But if you're using unit tests, then unit tests will tell you that there's something wrong with the program. So that is a really important distinction between the two approaches. Okay, so back to our unit tests. So obviously it's not returned 1992, it's returned 1993. So I think what we need to do now is we need to actually do the calculation. So I'm going to build out the rest of the function. So we're going to say import the date time library. Import the date time library, and then exactly how we did it before. So I'll take the current date, date time, and then what we'll return is the current date, the year of the current date. Take away the user age. And then, of course, we also want to make sure that we convert the user age to a string. Or do we need to do that? If we're passing in our input as an integer in our test, then we actually don't need to convert it. So it is a little bit different to what we did originally. And then what we should find now that we've written our function properly, is that the test passed. So you get a nice green notification. And then going forward from here, if we wanted to just make sure that it was dynamic as it should be, and it can work with lots of different ages, and it will always calculate the right year, we can try a few different tests with different inputs. So here I would expect 27. If my age was 27, I would expect to be born around 1991. So again, I'll run this, and what we find now is that we've got two passing tests, one for 26 and one for 27. Okay, and that's pretty much that's all I'm going to cover today. But that's the how you do unit testing and how you would approach test-driven development for a really simple application in Python. Yeah, so that concludes the webinar. Are there any were there any questions at this point? Did anyone sort of type anything out?
Hi, Chris. So
Hi.
I've got a few questions coming up right now. The first one says, how does test first help us with maintenance? So basically the benefits of test first.
Sure. So yeah, so some of the other benefits of test first that I didn't cover, especially with maintenance, are if you've already got an existing program that you need to make changes to, and you want to check to see if those changes that you're making break any of the requirements, the existing requirements of the code. You can use your tests that other developers have written to make sure that what you're doing isn't causing what's called a regression or causing any of the existing behavior to break. So it's a good way to prevent new bugs and new glitches getting into your program. So if you've done test-driven development from the beginning and you've built up a suite of tests around everything, when someone else comes to edit your program, they should never, hopefully, they won't do anything that breaks any of your existing code or kind of expected functionality. I think that pretty much answers that question. Was there anything else?
Yeah, there's a few questions here. The second one was, what are the main differences between Python 3 and Python 2.7?
I'm not entirely sure of the intricate differences. To be honest, that's probably one that's better explained by Google. I think it's a lot of it is the syntax has changed. I guess to say it's been cleaned up is probably a subjective view, but I couldn't tell you off the top of my head what kind of the main differences are. I think it's probably best. I mean, Sam, you might know. You might be able to answer that, but I'm not really sure, I'm afraid.
Syntax, Python 3 adds a few more sugar syntax, so make your code a bit more elegant, and it supports a bit more data tuples and dictionaries. So it's aimed at improving the writing of code for data scientists and data analysts, people who work with data structures. And it's supposed to be slightly more performant.
Do you think it's fair to say it makes it a bit more like consistent or kind of like intuitive?
Yes, it's supposed to be more. It's supposed to be easier to write. Basically, that's the idea.
Yeah.
The major differences. The main concern is it's not a simple port between 2.7 and it is a simple upgrade, but it's not a simple downgrade. Because some of the sugar syntax that you get with Python 3, you don't get with 2.7. So for example, when you're printing a statement, you can print it really easily in Python 3, where it's just print and then quotations and then write whatever you want. But in Python 2.7, you have to add the brackets and it's slightly more verbose.
Right.
All right, so next, our friend here is asking, how can I get my company to write tests or do tests first?
I guess it depends on who you have to pitch the idea to in your company. I think the biggest selling point for pretty much anyone who has to work or use your software should be that it improves stability. It will decrease the chances of bugs getting introduced into the system, existing things or new things that you're building. I think depending on like how you manage requirements and things, deal with specifications, and if you're part of a team, how your team is run, it can also be a good sort of segue if you're doing something called behavior-driven development. You can kind of specify your requirements for the software in a certain way that will segue quite nicely into writing unit tests, and then that will produce the code. So yeah, I would probably, just to sort of summarize that, I would say it should definitely increase stability. And also something to look up is something called behavioral-driven development. So it can help you produce code that much closely meets the requirements and sort of specifications that you're given.
Right, sounds good. You spoke about a behavior-driven development, which brings me to my next question, which is basically what are the main differences between test-driven development and behavior-driven development?
So they're not different in the sense that you would do one or the other. I think behavior-driven development is kind of a practice for, or it's something that you would do as a complement to test-driven development. So you would do that as a way to define the requirements or what sort of is expected of your program. And then you would also use that as a means to do, if you had a QA on your team, a quality assurance person, as a means to sort of check that the software is doing what it's supposed to do. But what you can do is you can take your behavior-driven development specifications and then use them to literally name, like we did earlier with our sort of functions here. You can sort of you can take your behavior specifications and then just use them to write your tests. It's a little hard to explain exactly how it's done in a just kind of a short answer, but yeah, essentially it should sort of help you segue from software specifications into writing code. I hope that's a good answer. I mean, Sam, what do you think?
Yeah, it is. Just to elaborate on that, I think the main difference between them is the fact that when you're working in a company where they're trying to describe a feature or trying to describe how software works, behavior-driven development is aimed directly to using the business nomenclature, so using the language. So if you get the code up that you were sharing, I'll give an example. They would just use words like what you're using now, but rather than using when user, they would use something like when a customer or when a buyer or when a seller. And they would sit with a QA, a quality assurance engineer, to describe the feature. They would write their test scenarios. These are part of the requirements gathering. And then those requirements are then implemented as tests. So if anyone asks, how does this feature work? How do we log in by Facebook on this page? They can give them a test case. And it's very, very English oriented rather than code oriented.
Yeah. Yeah. Natural language.
Exactly.
All right. So next, this question is coming from Twitter with Ahmed saying, how exactly do you debug if you are using an editor?
Yeah, that's something I didn't cover actually. That might have been quite good to cover. So if you're using Atom, I think it can depend on what would depend on what editor you're using. If you're using Atom, there's a Python plugin, and that will have sort of keyboard shortcuts and buttons and things like that commands that you can use to step through your functions. If you're using something like, there's another one called, I think, PyStorm, I think made by IntelliJ, that'll have a debugger built into it. I think, yeah, it really depends on what tool you're using. But if you're using a programmer's text editor like Atom or something like that, or Sublime, the tooling will be, there'll be some documentation on how to get that debugging environment set up.
All right. So I think that's all of the questions I have.
Okay.
Sam, do you have any more questions?
No, not for me.
Okay, so thanks a lot, Chris, for this. This was very informative. We have learned quite a few important things about Python 3. For those of you who are watching on YouTube, we will put a link in the description for you to download Atom, which is the text editor Chris was using. And we'll also link an article that we got you through installing Python 3 on your machine. Thanks, everyone. And thanks a lot for your time, Chris.
No problem. Okay, thanks very much.